Good morning, Jen, sorry. One minute to go.
Okay, it's 8 o'clock and we're going to get started. Good morning, everyone. This is John Resso with Wells Darby, and with us is Dave Holdorf from Taco.
Morning,
I'm the
all.
bald guy. I'm the bald guy without the headphones. Dave's the bald guy with the headphones. We're going to talk about Taco today, and we're going to bring it to you from a little different view. We're going to be talking more about the plumbing side of the business, and we're going to show you and introduce you to some of the products that Taco has available. And along with that goes a lot of opportunity for you guys in the field to really engage with the homeowners and ask the questions. So we'll start this out. We're going to throw a few poll questions up throughout. We got Anthony Tassi with Wells Darby in the background. He's going to be handling questions and poll questions. So if it's your first time on a webinar, on the right-hand side of your screen, there's a little bar there that says questions. If you click on that, that'll open up the box. You'll be able to ask any questions in there. Anthony will be on the backside taking and answering all those questions as we go. And if he needs to jump in and stop us and get a question answered, he can do that, or he'll just answer them live as we go. So without further ado, we're going to start. Water concerns. So here's a house that's flooded. That's always a big concern. A couple different ways, right? You could have a plumbing emergency and could create this, or we could have one of 5 million water heaters that have some type of catastrophic failure. Average water heater life is 5 to 7 years. So this is a real problem for us in our industry. And if you've been in this industry any length of time, I'm sure you've seen some type of water damage within a home from either a plumbing type problem or a water heater failure. So with that in mind, Taco has what we call a flood breaker. This is a whole house shutoff. This would mount directly onto the main entering the house. We have them in 3/4, 1, and 1 1/4 inch pipe thread. 15.5 gallons of flow. That's important to know. It can be mounted horizontally or vertical. We monitor either volume, time, or a flow rate. And we have several different programs you can put in there. Leak protection, you could go on vacation. Has an audible alarm. Also has the ability to hook a floor sensor to it. It's driven off of either batteries or a 9-volt DC plug adapter that comes with it. And another nice feature is it has the ability to have a set of contacts. So if you have an alarm system within your house, you have the ability to tie this into your alarm system, and you will get notified through your alarm system that your water in your home has been shut off by the flood breaker. So again, this is a whole house shutoff system and readily available. In addition to that, we step it down a little bit, but this is a very convenient piece. This is a leak breaker. This goes directly on top of some type of water heating device. It could be a water heater, it could be an indirect water heater. It goes right onto the cold water inlet. And what this has the ability to do is, based on having sensors around the water heating device, we will recognize that there's a water leak and we will drive that valve closed. So this is a true full ball valve here, full port ball valve. Same head that we use on our zone sentries, just programmed differently. Here it is on the install. It ties directly into the leak breaker, which is mounted in this scenario on the wall. And we have Molex connectors that tie them together. So super easy install. If you're there putting a water heater in, it's a quick add-on. We have 2 versions. We have a standard version, and then we have an E-Link version. So if someone wants a Wi-Fi type version, we do have that. You're looking at it right here, Wi-Fi E-Link. That has the ability to send either a text message or an email one direction, saying that your water to your hot water heating device has been shut down. And that will alert you that, when you go home, obviously you're going to have no hot water and you want to figure out why. How we would recognize it here is the little water sensors that you see right there in the center. So that will go on the floor around the water heater. There's little tabs that keep it up off the floor a little bit so that you won't get any nuisance lockouts. Put that right in the drain pan. If that sees water, it will close the contactor. It'll send a signal to the leak breaker. The leak breaker will then drive the leak breaker valve closed, which will shut your cold water main off going to your water heating device. So if there's a leak at the top of the tank, you'll have minimal amount of water. If there's a leak at the bottom of the tank, you'll have the volume of that tank on the floor in the pan, but you're not going to make an indoor swimming pool out of your basement. And we have the ability to add sensors. We can go up to 10 sensors in series. And we have the ability to wire those together, daisy chain wire those together, up to 200 feet of wire total. So with those 2 products being covered, we're going to jump right into a poll question. Make sure everybody's awake and alert this morning. Go ahead, Ant, run a poll.
All right, good morning, everybody. First poll, how can someone protect their homes from flooding if they have a leaking hot water heater? %58 voted so far, 61, jumping up some numbers here, good.
Yeah, answer your questions right on the screen itself.
$75, $77, 40 seconds in.
Now, one thing to remember, everybody, about when we're looking at water protection, leak protection like this, homeowners don't know this stuff exists out there. They have no idea. So if anybody has ever experienced water in their basement, this is something to present to them. They have no clue. All they really know about any type of leak detection out there is going to be what they can find in the big box stores. It's a little thing that sits on the floor. It's a couple of contacts on there. It gets wet and it makes a lot of noise. And
Right.
that is it. Think about this for a homeowner. Most homeowners don't even know where their main shutoff is. So these two things are kind of important to consider, and open up a whole new industry for a lot of people there.
All right, how do we do, Ant?
So share, we got 93% on the leak breaker. So everyone's paying attention so far, John. It's good.
Oh, 2 slides in, we're doing great, thanks.
All right, those 4% that answered large sponge, love you guys. That means you're really paying attention there. So good job.
You have to have a really long handle on that ball valve. So
All right. Why am I hung up here? All right, so we're going to start talking about domestic water recirculation and why it matters. So you go back to the 70s, you know, your average home size, 1,600 square feet. Today, we're about 2,000, 2,400 square foot for your average home. What does that mean? That means that normally we'll have greater distances from whatever we're using to produce hot water. So let's say in the 70s, it was 30 feet of copper pipe coming from our water heating device to our faucets. Today, because our houses are larger, that distance has grown to approximately 80 feet. And these are just random numbers we're using. So, you know, this isn't, exact, but these are some numbers that we've put together. So hot water fixtures means, people have more demands, more needs. Everybody has to have a double sink in their bathrooms and just more hot water faucets in general. So we went from approximately 6 faucets in the 70s to 12 faucets today within a home. So because of that, that means we have more water demand. So more fixtures means we need more hot water, which means more volume. In order to support that greater volume, we need larger diameter pipes. Larger diameter pipes hooked to these new either 1.5 gallon or 2.5 gallon shower heads, even though I'm showing you some large range shower heads over here. This means our flow rates are going to be, we're going to reduce the flow rates, but we're going to increase the velocity. And that means that it's going to take longer to get the cold water out of the pipe and get our hot water delivered to the faucet that we're at. And that's approximately 18 times longer it's going to take. So I could potentially be wasting up to 32 gallons of hot water a day with a family of 4 just waiting for hot water to be delivered to my faucet. So I get up in the morning, I go in, I turn my shower head on, I brush my teeth. By the time I get done brushing my teeth, the hot water has finally made its way to the shower. That's what we're talking about here with wasting of water. Homeowners don't know this stuff exists, as Dave said earlier. If they go to a hotel, it's funny how they turn the hot water on at a hotel and there's never a delay for hot water, because hotels have recirculation systems within the hotel. Means every point of use, there's hot water waiting. Well, you have the ability to offer that directly to a homeowner in any residential home today, and we're going to go through the reasons why. All this water wasted, you could fill a 10 by 20 pool up 8 feet deep in a year. So that's what's going on. We want to make sure that, a homeowner knows you have an opportunity here to upsell them and really make them more comfortable. So we're going to take another quick poll question. Go ahead, Ant.
okay, it's on your screen, gentlemen. You can just choose your answer on the screen as you see. So question, how many gallons of water can a family of 4 wasting waiting for hot water at their faucets? How many gallons can they waste?
Now, this is an interesting number to look at here because if you think about your own home, if you wait for hot water, You know, it might be 10, 15, 20 seconds, maybe not a long time. But if you know you wait for hot water, what's the normal sequence on what you do? You turn the water on and then you go do something else. You might go brush your teeth. You might go ahead and put your clothes out for the day, things like that. So sometimes that water could be running for a couple of minutes before you go and jump in that shower. So this is the idea behind here about hot water recirculation and not having to wait for that hot water as we're going through and instantly knowing that you can just jump in and get it. Again, homeowners don't know this stuff is out there. As far as they know, they live with it. It's just the way it is. When we think about that 1,600 square foot house, we didn't have to worry about it because there was more people in the house and one bathroom. The pipes never got cool. All right, never cooled down enough. Now the pipes cool down and people just live with it. So again, another avenue to make us superheroes to our homeowners, knowing that we can make them stop waiting for hot water.
Gentlemen, we had a good question here just to kind of pass it along. Can you go 200 feet with the flood? He has flood stopper sensors. I believe he meant the leak breaker.
Leak breaker,
All right,
you can daisy chain them together. Maximum distance with them daisy chained together is 200 feet. Yes.
Okay.
Yeah, 200 feet total of wire.
Right.
Each
Total
sensor
wire.
comes with 10 feet of wire, just using 18.2 thermostat wire to extend that sensor if need be. But 200 feet for the leak breaker. For the flood breaker, that I'm not 100% on how far you can go with the sensor with the flood breaker. You can only put one on there. It doesn't take multiples in series like the leak breaker does. So I'd have to get back to you on that. But typically the design for the flood breakers sensor is to catch the amount of pipe that does not, that's before the sensor coming in from the street from the controller itself. So that's the idea where you mount the controller, you can use the sensor there because then the flood breaker is monitoring the water usage throughout the rest of the house. So sensors are not necessarily needed because it looks at it a different way.
Yeah.
Yeah. And whoever had that question, just leave us your email and we'll get you the answer and we'll email it back to you. You can put it right in the question box. Anthony will grab it and we'll get the answer and we'll send it back to you.
All right. So I got the results. We're going to share them here. 12,000 gallons. 74% of you were correct. So congratulations on that. I do have another question here. If I can share, can one use a leak detector in series with a hot water heater and a boiler, both direct and indirect, and he's /GHA condensing furnace? So I guess we're asking if we can use one shutoff with multiple sensors, I would imagine.
If they're close,
With the
if
leak
two
breaker?
are close
Yep,
together,
get it, John.
if the boiler and the indirect are close together and you're on the same cold water main that would feed both of them, and you had a sensor under the boiler and a sensor under the indirect, or multiple sensors, yes, that would shut off the main to the boiler and to the indirect. So that
Right.
could be.
Yes, direct. The leak breaker was originally designed as a water heater protection device. But then as we started developing it even further along, we were looking at adding more sensors. So now you could actually use the leak breaker as a whole house protection, not just the water heater, and then just continually add those sensors. So yes, drop one by the water heater itself, drop one by the boiler and indirect tank, put one over by the laundry room. Because all we're doing is daisy chaining our wire from one sensor to the next, work your way down the line. And then as you get further down, maybe get to the kitchen space, drill a little hole just for that 18.2 stat wire to head up underneath in the cabinet itself, drop a sensor there. So then we can use it as that whole house protection, not just for the water heater itself. So excellent question.
Yeah, we just got to watch the flow rates there, right? When we're all said and done.
Right, right. So yeah, the leak breaker is only a 3/4 inch ball valve, but it is a full flow ball valve. It has a CV of 37, which means
Right.
if you were to flow 37 gallons a minute through that valve, it would have only 1 psi drop. So if you had a house that had larger than a 3/4 inch line, you could still put it in. It might look a little funky, but it would probably do the job. I mean, how many homes do we run into that are going to require 37 gallons a minute flow? and then experience a pressure drop with that flow. So,
All right, back to research. So what do we got here? Taco has what we call a hot link. A hot link is a domestic hot water research system. This device will go directly underneath a sink. So on the top here, we have cold water going up to your faucet. We have the hot water going up to the faucet. Your cold water enters from the right. Your hot water enters from the left. And here we have the thermal disc. This is a removable part. So if there's ever a part failure, if it ever needs to be cleaned, it's removable right under the sink. You don't have to replace the whole device, which is very nice. What does it look like? How does it work? So here we're showing you two different sinks, and we're showing you the device as it's starting to work, and then we're showing you the device as it's delivered the hot water to the sink. So in the upper photo, we've turned on, the circulator is on, it's running. We're pushing water across, pushing it back down the cold water line. The whole time, this little thermal disc right here, this thermal disc is sensing temperature. When it feels the warm water, it will close. When that warm water is there, it closes. Now we have hot water waiting right here at the sink for us. And yes, we did push some warm water down the cold water pipe, but we are delivering hot water to the faucet. So just keep that in mind. We are using the cold water pipe as our return back to our hot water device. This is a cutaway.
the bleed by that we typically experience going by one of these things with our design to it is about a cup to a cup and a half. Cup and a half of water is not a lot when we think about it. That's the amount of time it takes to turn the water on to get your hand underneath the faucet. So to do that bleed by. So there's a lot of different bleed bys out there, or a lot of crossover valves that have bleed by. Some are much higher because they act a lot slower. As John goes through how this thing works, it's a very quick system that we have here.
So here's a cutaway. Again, the cold water would be coming in here from the right and going directly up to your faucet. This is our thermal disc. This is a check valve. This is the removable cartridge. So if you ever have to replace or clean, the cartridge is removable. Your hot water comes in from the left. It runs through here. The circulator will push it through the check valve, back down the cold line. As soon as we recognize the hot water, this thermal dish will close, and now the hot water is right here at the faucet, ready to be delivered to the faucet. So the wait time, the draining of the cold water in the hot line, that all goes away. And in this type of system, we do not have a dedicated return line. So that means you have an opportunity to go into any home. My house, my master bathroom upstairs, I have a 3/4 main going all the way to the upstairs. It takes 3-4 minutes to flush out that line every single time. I have a hot link now underneath there. I don't have to, have my wife tell me I'm waiting for hot water again. I'm waiting for hot water again. Now I have hot water right at the sink, ready to go. So what would it look like? This is your typical system. We just took four different devices that use water: a washer, a kitchen sink, a shower, a bathroom sink. And that is your typical install. And there's no recirculation on here. So if you were all the way down to that, we'll call that a bathroom sink, all the way down on the right, you would have to flush out the water from the water heater all the way to that sink every single time you went to use it. So if that's something that a homeowner is frustrated with, you have that conversation with them and they tell you they'd like to have hot water faster. Pretty easy. You buy one of the kits Dave will go over later. You're going to add a little 006 E3, and you're going to mount the hot link directly underneath the sink. This will be mounted under the sink. There's several different kits. It can come with the stainless steel hoses. It doesn't have to. Depends on how you want to do it. And you're going to install this little circulator over here at the hot water device. It can be a A.O. Smith hot water heater. It can be an indirect. It can be whatever is producing hot water for you.
Except
it's tankless. We're going to get into that. Dave will get into that later. So we'll come off of here. We'll circulate the hot water all the way down to the furthest run. It will go through the thermal disc. It will push a little bit of water back down the cold, all the way back to the water heater. And when we see approximately 150 304-degree water there. It'll close the thermal disc and you'll have hot water waiting at the faucet. That's how the HotLink system works. Pretty basic. Everything you need will come in these kits, and Dave will go through those in a little while, but that's a recirc system with no dedicated return line. This is what a system with a dedicated.
Before we go further, we got a couple of questions here.
Okay. Go.
First question, it says, does, doing this style system, does it overpressurize the system itself? So by adding, I'm sorry, I'm going to go back 2 slides, just so we have showing the picture of the HotLink here. We're not overpressurizing because it's street pressure. And yes, we're adding a circulator to the system, but the circulator is not adding any pressure. It's not a pump. All we need to do is move a little bit of water around here. So if you take a look at the piping here, we're putting a circulator here. We're going around the line, crossing over, then coming back to the water heater and then back out again. So we're not adding any pressure into the system itself. So there's no worries of that. We're using the cold water line as a return, not a supply like we're used to, but this is a very viable option to add hot water recirc into homes with very minimal construction going on into the house itself. It's the hardest part is actually putting in the circulator on the hot water supply line. And then the crossover valve. So this is still going to operate on your street pressure that you have in the house itself. The other question was, what is the material of the HotLink valve? It is a composite plastic. All right. It is a very high temperature, high pressure composite that we have in here. So you're not going to hurt this thing. This thing has all the NSF ratings behind it. We have beat the heck out of this at the factory itself. We do have 1/2-inch connections that are going to be on here. All right, so you're going to go with your standard hose connections that you need. And as John was saying before, if you needed to take this apart and clean it, you undo one connection rather than replacing the entire device. All right, I'd rather undo one than do 4. And also, very important, if you guys all see the camera, see my camera here, the cartridge has a hex configuration on the end here. And this is for taking it apart. You do not want to use this for putting it back together. When we already shipped this out to you, it's torqued down the proper torque. It should only be hand tight if you've ever taken this apart, because if you put a wrench on this and tighten that down, there's a possibility you're going to bottom that out. And if you bottom this out, again, there's another possibility of this thing chattering underneath the sink. So you don't want to do that. So just put it hand tight, that's all, and that's it. Another question that pops up is, can you get the check valve out? No, you cannot. There's no way to, if you ended up experiencing a bad check valve, I would just replace the whole darn thing here. So the check valve is press fit in there. It's not going to pull out at all, but just pull the cartridge out. Now, we don't sell the cartridge as a by itself. It's the whole device. Right now, this is just a little check valve and a hunk of plastic. So you toss that and you replace that if need be. If you found a check valve was stuck, then replace the entire unit. Because we don't all live in Maine near the Poland Spring. All right, so we do have some water that's going to clog these things up, and that's the idea of the cartridge design. And we also put a screen on the top here. So that screen on the top is going to prevent a lot of the stuff getting in there. All right, and fouling these things up. If you happen to notice it really fouled up, I would take it apart. It's stainless steel, put it in a bucket of CLR, clean it, brush it out, put it back together. It'll probably work again. Oh, what's the warranty? The warranty is a 1-year warranty that we have on these things.
That's all our questions for now.
I guess another question is in regards to recirc. Is it now a choice between wasting water or fuel? And how does this work with a domestic coil and an oil burner? Yeah, that's an interesting question there too, Tom. When we look at different scenarios of, are we using that much more fuel in order to deliver the hot water out to somebody's home? Well, that will depend upon a lot of variables on how much extra fuel the water heater is going to trigger off. If you had an indirect tank is losing maybe a 1/2 degree an hour. So it takes a long time for that thing to cool down. And we're moving just a small amount a small amount, about 0.2 gallons a minute across the hot link valve. So it's not a large flow of water like it would be in a heating system where we see that circulator running. This is 0.2. We're trickling water out there. So what I mean by the other variables is how much pipe, is it insulated? Is it uninsulated in a cold space? Because now the pipe ends up becoming a radiator. So that's what happens there. I would say for most residential homes in our area, we have our pipes in the basement. The basement may be heated. We're not seeing excessive amounts of runtime or extra runtimes in our water heaters already. So we'll talk about how we control that also later on. That may also depend upon the control. So the control will also denote how much of that too. And we'll talk about that.
All right, everybody's good. Thank you for the questions. That's great. I'm sorry, this is I don't know if we covered this one fully, but this is a recirc system with a dedicated return line. So, you know, we come off the water heater, washer, kitchen sink, shower, bathroom sink, and right here where we had the hot link before, now we have a line that goes all the way back to the water heater. So this is a dedicated return line. So when this circulator turns on, we're just going to create that pressure differential, pull the water around the system, put it right back into the bottom of the water heater. So if they have a dedicated return line, you know, there should be some type of device in there already that's moving hot water. You can go to the 006E3 and save them some electrical, you know, savings. And Dave's going to go through some other methods of controlling it. One thing on these circulators, which Dave will touch on again, is you see none of them have fittings on the end. We left them like that on purpose. So that would be a talking point for us, and Dave will cover that in a little while. All right, poll question number 3. Anthony, you're up.
All right, number 3, a recirculation system can be installed in a home without a dedicated return line. True or false? Gentlemen, we're just getting some questions about how to connect that crossover valve with 3/8 inch compression. I believe it's half by half. I think the tappings on your faucet is the same as the tapping on the top of that crossover valve. So you need a different supply hose.
Yes, it may depend upon the faucet that you have. So yes, this is going to be a standard 1/2 inch connection that you see there.
Yeah, it's a straight thread. Usually it's a 1/2 inch straight thread.
Yep. And Dave, you'll cover that in a few minutes anyway, right?
On the circulators, yes.
Yeah. And the line sets, right?
Correct. Yep.
All right, 74% voted already. I think we can close this one. It looks like a done deal. We'll share the results. And it looks like 93%. Yes, it is true. You don't need to have a dedicated line. Excellent.
Great. All right, we're going to roll this over to Dave. He's going to run you through for a little while here. Thank you, everyone.
All right. So now we're going to discuss a little about circulator sizing when it comes to hot water recirc. And there are so many different rules of thumb that people have in their mind on how to size a circulator or what to put into a system itself. And we're not going to go through all this math that I'm showing you on the screen right now, because if you started trying to figure all this out in a residential setting, your head's going to explode, and it's never worth it. So, meaning the exploding heads. So, you know, but technically you need to know what flow, you know, what's your gallons per minute flow you need in the system? What's the head loss? The head loss is going to be based upon the amount of pipe that you have there, how many fittings you have, elbows, T's, valves, how many BTUs do you need to deliver? Meaning, what's your temperature drop of desired for a hot water recirc? What's the coldest water you want it to go to, or the less warm water going out to a system itself? So it can get quite complicated in a residential setting. Commercially, these numbers are important. All right, we need to know this for doing a commercial application, but in a residential setting, we've tried to make it a little bit easier for you. We go ahead and take a look at this first chart here, and this chart is showing us your house. If you had a 1/2 inch supply coming off the water heater with a dedicated return line with a 1/2 inch pipe coming back, the 006 has been the most common circulator out there. And as you see here, you can do about 300 feet of pipe with this. all right, 150 feet away to that furthest fixture with a 006. Now the 003, you'll say, well, hey, that works out pretty good too. I mean, that half-inch supply with a half-inch return, that's that house that was built in 1970, all right, where we had everything stacked. It's really hard to get 300 feet of pipe in that house, meaning there and back again. So, but we end up going with the 006 more often because honestly, the cost difference between manufacturing a 003 and a 006 is so close to each other that most people just keep 006 in stock. Now you might say, well, so what? Great. Bigger pump, better. Well, bigger pump is not better. What we end up having with a 006 or too big of a circulator is we have velocity issues. We end up with a high velocity of the water flow in the house. And by having that water move too fast in a plumbing system, we can actually start eroding the pipe from the inside out. I have seen this before, pipe failures, copper and PEX. All right, my previous life, I'm with Taco now 8 years. My previous life with PEX, with Uponor for 15 years. And I'm seeing these failures because we have too big of a circulator that's out there. Now, when I talk about this, if you've noticed on this chart, talks about nothing about the height of the structure. Height of the structure is irrelevant. All right, not necessarily irrelevant, but the height of the structure comes into play just for the length of pipe that it took to get there. And that's why I see a lot of bigger pumps installed, because people are taking that height of a structure into account, saying, well, I'm going up 3 stories, that's 30 feet, so I've got to have a pump that can do 30 foot ahead. Well, think about this for a second. If there's no recirc installed and there's no pump installed, is the water already sitting up there on the 3rd floor? Yes, it is, right? Why is the water already up there, sitting there at the faucet? Because the street pressure is pushing the water there. By having that street pressure, by having 40 PSI in the lines, 80 PSI in the lines, we're pushing that water all the way up to the upper levels. So you don't need to pump it up there. Our circulators are just meant to circulate it in a circle, bring it up and back down again. We're just moving it around. What goes up one side's got to come back down the other. So it acts like a Ferris wheel. So if we go take a look at the most common, as we see in our homes today, more 3/4 inch supply with a 1/2 inch return, that 006 is doing up to 550 feet of pipe. And then the oddballs, when we see a 3/4 supply and a 3/4 return, 1,800 feet. So in hot water recirc, a 006 is a big pump. It's a really big pump. So we don't need that much circulator for these things. So what are we doing at Taco to combat that? What we're looking at is now making the circulator variable speed, meaning set it up for what you want it to do. So we came out with this circulator about 1.5 years ago, the 006 E3. It's not a 3-speed circulator, low, medium, and high. What we did with it is make it a variable speed dial. So based upon the length of run of pipe that you have in the system, you turn the dial to where you want it to run at. So you get the effective flow in the system itself and also doing what it's supposed to do without the high velocity out in the system. So here we take a look at the 6E3. All right, you can see also on my camera, I've got one on my hands. All right, there's the dial. All right, at the top of it, you turn that dial to where you want it to go. There's an LED light, so when it's operating, you know it's on. All right, we'll talk about how to turn these things on in a little bit. And the other thing that we did to make life easier, between the 003 and the 006, each one of those had 4 different connection styles. 4. We had it sweat, we had it thread, we had them flanged, and we had union connections on there. All right, and it was like a weird 1-inch union too. So it was an item that wasn't really in stock all the time. When we developed it back in the day, that was the most common at the time, but not now. Now we went to this 3/4 inch or smaller union connection, and this is the one way it comes. So now what we have is a sweat, a thread, a press in 1/2 and 3/4. So the circulator does not come with any connections. You need to get that separately. You got to remember that. And to help you out with that, if you pick one up, if you look on the box, when you go to open it up, it says it right on the box, right on the top cover. So you can't not see it. So we put it there, and then we also put it right there on the side. All right, right above this would be the label, more of the data about the circulator itself. All right, mine doesn't have it because I know some people. So make sure you get the fittings based upon how you want to connect it up there. And these are standard union connections that are going to be in stock. They're also the same connections, the same fittings that we use on our mix valves. So nothing special there. The only difference is mixing valves come in a bag of 3. This comes in a bag of 2. One of the biggest differences that we've done with this circulator too is that we've included what we call Sure Start. So Sure Start is an automatic correction feature built into the circulator itself. And Sure Start says, it's going to prevent the circulator from dying, which means 2 things kill circulators prematurely other than a long life: getting airbound and getting seized. Those are the 2 things that make circulators stop. When it gets airbound, we need the water inside the circulator to help lubricate and cool down the bearings. But when that circulator doesn't see that water, it's going to burn out the bearings. This circulator will sense that there's no water inside, and it will slow down and then speed back up again. It's just a quick drop in speed, kind of like taking a ball valve and jamming it open and closed to try to move that air bubble out. This circulator will do it automatically. It's not going to purge your system. It's just going to purge the air that's in the circulator itself. When it does that, the light on the front of the circulator flashes white. Now, if you've ever installed one of these in the heating system, you'll see that same thing. It flashes white for a second, and then it goes on. All right, that's just that initial air bubble moving it out. You normally only see that on startup for the first time. Now, the unblocking, that is pretty unique and pretty cool in what it does. And, you're not going to see the unblocking on an initial install. You'll see that years down the road. The tolerances between an impeller and the casing are really tight. So what could happen is you get a piece of sand, you get a solder ball, you get something stuck inside of it, and the impeller starts to spin, and it can't. Now, my contractors that are here, if you've experienced that before, I know you have, a seized circulator. Usually in the heating world, you'll see that in the fall. And what ends up happening, you walk in there, the call for heat is going, it's cold in the house, it's not flowing any water. The circulator, the motor itself is getting really, really hot. That green paint starting to turn brown. What's the first thing you do? So type that in there. Tell me what you do. All right. I know what you do, and I know what I want you to do too. All right. So my installers out there, it's basically whatever tool you have in your hand, you give this thing a couple of whacks. All right. I know you do, and I want you to. There you go, Manuel. That's right. You said you hit it. Yes, please do. When you hit that, you're jarring what's ever free in there from spinning, and hopefully it starts up. If it doesn't, all right, that's when whatever's in there is not coming out. These circulators, the Sure Start is taking it and actually shaking the impeller inside. All right, real quick, about a second and a half, and then it goes up to 5,000 RPM, regardless of where the dial's set, and then comes back, tries to go up to 5,000 RPM. If it's not spinning, it's going to happen for about 20 minutes, 100 times, all right, and trying to free it up. If it doesn't free it up in that 20-minute time period, the light turns red, the circulator turns off, and basically says, dude, come fix me before I burn out. There was a job site I went to once, and I pulled out a splinter about 8 inches long that was jammed into an impeller that wasn't letting it spin. All right. That little bit of shaking is not going to break a splinter and allow that to flow through it. But we saved the circulator, just had to take the 4 bolts out, and hey, check that out. So that's what we've done that. Question, does the pumps only come in the composite housing? Yes, that is correct. These are only in actually, I'm sorry. Today they are available this way. In a couple of months, probably third quarter this year, later this year, we have already designed this in stainless. All right, so you will see some stainless ones coming out later this year, but we do have it in a plastic composite already. I found a brazing pad once in one. Oh, there you go, man. Yeah, you ain't, doesn't matter what size hammer you're using to hit that thing, it ain't going anywhere, right? So, or even if you had the Sure Start. Now, remember about Sure Start, you don't tell it to turn on. This does it all on its own, all right? It's going to just sit there and go through that. Most people don't even know what happens in their homes. So if we want to take a look at what circulator is going to do, all right, we take a look here, we see the pump curves. we're giving you some reference points on the dial. If you knew the flow and head in your house or in your application, then you turn the dial to run that speed. But what we also did right on the top of the box, based upon a 3/4 inch supply with copper and a 1/2 inch return, where to put that dial. So if you look at the bottom, you see at the low setting, it's just about in the 9 o'clock position, you're getting 200 feet of pipe. I would say that's going to be most homes, most applications. And guess what? When you have it set there, it runs about 7 watts. If you have PEX, then there's other calculations you can do. As we say, a note down there, take a look at what they are looking at. And in my house, I have an 85-foot supply with 3/4 PEX and a 1/2 inch return, and that's about where I have it. I tried turning it down even lower, and I couldn't get any more flow out of it. So I wasn't getting the hot water out there. So that was about where I played around with it and got it to run there. Straight up at 12 o'clock, going to get 350. And if you turn it at that 230 position, you've got about 500 feet where the old 006 was. So we put markings of the 6 and the 3 on there in case you're pulling one out and you want to make sure your operation's still the same. Now, how do we control hot water recirc? Excuse me. One, I have seen this a lot. You take the pump, you plug it in, you make it run 24 hours a day, 7 days a week. Well, the only place you really should see that is a hotel or an apartment building, all right? Because most people use water on a schedule. Now, if you want to make it different, you want to save a little bit of energy and not make the boiler fire off so much or the water heater fire off, you can put an aquastat on it. All right. And when that aquastat reaches reverse aquastat compared to our indirect, and when the temperature gets high on the return pipe, if you had a dedicated return line, it says, all right, I'm warm, don't need to run, shut down. Well, in conjunction with that too, you can also put the circulator on a timer. And we've had them for many years. We call them the plumbing plugs. It had a timer built right onto the face of the circulator itself, right there. And you basically turn the timer to the dial of the day, had little tabs along the side to represent 15 minutes of runtime, and run it in conjunction with a aquastat. So it runs, a few hours in the morning, few hours at night, and then you rock and roll from there. And then the aquastat says, hey, I don't need it to run anymore either. So that's actually a very efficient way to do it. However, the timers are just like those timers that you have for your Christmas tree, if you remember growing up. All right, because you plug that into the wall and you couldn't get to the outlet. You couldn't reach it to turn it on and off. So you put one of those things on there. And they're great for the couple of weeks you got the Christmas tree in. But think about this. What happens often? We see power outage. If you see a power outage, it screws up the clock. Daylight savings screws up the clock. Things like this, meaning the situation we're all in now, all right, where a lot of us are working from home. Your schedule changes. If you had a circulator that had a schedule and now your schedule is different, well, you're not going to get water when you want it to. So one of the things that we did is trying to make things a little bit easier. If we think about what thermostats are most popular today, what thermostat's the most popular out there? In the mind of homeowners. Yes, you're going to say the Nest. All right, the Nest thermostat's really popular. Why? Is it because they can program it from their phone? Not necessarily. All right. Can I see what's going on? Can I take a look at it? Yes, the Ecobees, very popular out there. The Honeywell T6s. There's so many different ones out there right now, that people like it. Why do they like it so much? Is because they program themselves. They got motion sensors built in to learn when you're home. So the heating and cooling comes on automatically. Heck, there's even, I've got a couple of them in my house, a couple different ones I was testing out. One of them even has geofencing, which means it knows where my phone is. So when I'm driving home, within a certain mile radius that I put in there, it turns the heating and air conditioning on. People love that stuff. When it comes to hot water recirc, that's what the smart plug does. The smart plug is going to take any dumb pump, any dumb logic, and make it a smart system and learn when people use hot water in their home. All right. And wiring this thing is not hard. All right. As you can see right here, looking on my camera, you can see you can plug the circulator right into that and plug that into the wall. If you can't do that, we need to consider getting out of the industry. Okay, you can just be the guy that carries the hammer to wax circulators. All right, and then there's a temperature sensor that comes along with it, and all we do is zip tie this to the hot water supply, and we even offer you the zip tie. All right, so you don't even have to find it, and you're done setting this thing up. So what's a smart plug do? What it does is it learns when people are using hot water. There's no motion sensors, there's no flow sensors, there's no nothing like that. What it does is it looks for a rise in temperature in the pipe, a duration at that temperature, and then a temperature fall. And then that's it. That's an event. It learned that event, and it's got a 7-day calendar with as many events as possible during that time period. So that's how it's going to operate. So let's say, for example, it learns a shower on Monday morning, and it was taken at 7 o'clock in the morning. What this thing is going to do is give you a window of opportunity. It's going to create an hour. So if it was 7 o'clock, it comes on at 6:30. It's going to go off at 7:30. And during that 1 hour window, that pie is going to run for 5 minutes on, then 10 minutes off, then 5 minutes on, 10 minutes off. So it's not excessively running either. All right. So it's really trying to make it as sufficient as possible and just flow just a little bit of water out to the system itself. So ideally great with the 006E3 because we offer that circulator with and without a line cord. All right. You get it with the line cord. All right. There's no wiring whatsoever. And that is it. You're ready to rock and roll. So it gives you that window of opportunity there. Now, if you take this and put it into a different application, say a hotel or an apartment building where there is no schedule whatsoever, then you can just hit the mode button that you see right at the bottom, all right, and change it to the pulse mode. Pulse mode is now just 5 on, 10 off all day, all night, all right. That would be really useful for people in homes that are home working today, all right, where their water usage is going to be all over the place. So now you just hit that button, change it to pulse. It's 5 on, 10 off. Still want to use the temperature sensor if you're in pulse mode, because whether you're in smart or pulse mode, the next thing it has is vacation. So if you happen to leave after 36 hours of no water usage, then the system just shuts down. It's not running the pump at all. All right, and trying to give you that efficiency. If you had a timer on it or an aquastat, it's still going to run while you're away. And then while it's been in vacation mode for at least 7 days, no runtime, the circulator is going to run at least 30 seconds every week or so to make sure it doesn't seize up. Yes, I know it already has the Sure Start built in if you had the 006E, but yes, you can use other people's circulators with this if you wanted to. If you happen to plug this into a red circulator, just make sure you have a green one around because we actually send voltage spikes back up the line and kill the circulators. I'm totally kidding there, people. Been doing a lot of webinars this week. I just want to have a little bit of fun and make you all smile out there. So,
hey, Dave.
Yes, sir.
Just fill them in on. You said your circulator at home's running on about 4 watts. Fill them in if they had a standard circulator. What the equivalent would be.
Oh, your standard 006. Yeah, your 006 circulator out there, or any other circulator around that size, is going to be around 60 watts. A 003 is 40 watts. This one goes up to a max of 44 if you turn it all the way up. 4 is at the minimum, and like I said, I'm running around 7. So my brother was doing renovation to his house, and I said, oh, let me run that return line before you sheetrock it. And I show up one day, and it's done. He rocked the whole thing, and I said, what are you doing? You were supposed to call me when the rockers were coming. And he says, I decided I didn't want to add recirc. I didn't want to spend the money in the electricity per year. I said, really, dude? You're serious about that, right? Oh, yeah. I said, you kind of know what I do, right? And of course, as most of us know, most of our family members and friends have no idea what we do, right? They just know that we go down to the dark reaches of people's basements and mess around down there and then leave again. I said, it's going to cost you about $7 a year in electrical costs. $7. You take into that ECM and a smart plug, like you see with the Smart Plus E here, it's $7 a year electrically. All right. Now, mine's a little bit different because I have it in the pulse mode now that I'm working from home and my mother-in-law lives with me. So we have different water patterns now. So I've set mine up in the pulse mode. So it's probably a little bit more. All right. All right, maybe $15 a year in electrical costs. But I'm saving about anywhere between 30 and 50 bucks a year in water. All right, so I'm saving that. Yeah, I might have a little bit rise in that fuel cost, but now I never wait for hot water. I mean, you want to be comfortable in your house. Again, most people don't know Recirc exists. All right, and they just live with it. So all of a sudden, you present it to them just once. They will always remember you when they stick their hands in cold water, saying, "Man, I got to call him back."
So Dave, what you're saying is if I had a circulator that ran 24/7, 365, it's like having a 60-watt light bulb on every minute of every day for a year.
Correct. Yep. Yep. And do the math on that. And based on where we are, as you guys all know, we're some of the highest electric rates in the country at, where I am on Long Island at 22 cents a kilowatt. All right. That adds up. That adds up. So if I can get a circulator from 60 watts down to 7, beautiful. And only run it for 5 on, 10 off. When you take those timer pumps, all right, people usually select those things and turn it on from 6 in the morning to 9 in the morning, 3 hours of straight runtime. When we put a smart plug in there, right, and even though we want it's still going to maybe run for those 3 hours, remember it's only running 15 minutes out of those 3 hours every hour. So we got a 45-minute runtime compared to the full 3 hours worth of runtime. So just things to think about as we go through there. Now here you see the Smart Plus E. This is a complete package, all in one box. So you do have the circulator with the line cord and the smart plug. You can get it separate. You can get it together in that box there. Still remembering fittings are separate. Okay. Things like that. And next screen. All right. Now this is showing your install of a smart plug here with a 6E3. And this is also showing our water heater with a mixing valve on there. When I have a mixing valve on my water heater, whether it's a tankless or tank style system itself, you want to take that temperature sensor and you can just put it on the mix side. If you do not have a mixing valve, I like to take that temperature sensor and put it as far down the line as I can. Don't put it too close to the water heater because you're going to get some stacking and that pipe gets hot. And the control is going to think there's always a call for heat or call for hot water in the house. It's always thinking there's an event going on and it will excessively run the circulator. So we want to make sure we push this as far down the line as we can. So this way it learns the proper events. And you've got 8 feet of wire. Try to use as much as you can, and a standard 18-2 stat wire if you need to extend it more, but I can't imagine needing more than 8 feet of that thing. And then we also offer as a package the HotLink Plus E. The HotLink Plus E is now also including the crossover HotLink valve, and you will also have fittings with the circulator. So in this box is going to have your 3/4 inch NPT male by female connection. You will also have the hoses, half by half hoses in the box to complete the whole package if you were picking it up and going to install that day. So you're not going to forget anything at this point. Now, again, remembering that HotLink and the HotLink Plus E is only designed for tank style water heaters because your tankless water heaters are looking for a high flow rate across the heat exchanger, at least a half a gallon a minute across the heat exchanger in order for it to fire. This thing's only doing 0.2 gallons a minute across it. And it's not enough flow to trigger a tankless water heater to run. So now tankless on a coil boiler, different story. All right, that is just working off a temperature of the boiler itself. So it would still work there too, yes. But a tankless independent fired water heater is going to not work in this application. We will show you what we can do there. One of the other questions came up, kind of both direct and indirect there. Yes, you can. Yes, you can use the HotLink there too. But we're just not looking at that tankless small wall hung boilers or water heaters up on the wall to do that. And another thing about the HotLink valves that you have out there in the system itself is that you can use it. You can put multiple valves in one house. All right, we're not just limited to just putting one of these in. In the kit, we only offer one, but maybe the plumbing's a little bit different in the house. The water heater was in the center and we teed off and went in different directions. So you can put one on either line, all right, all the way down, up to 6 in one house. I usually consider the most critical rooms of the house. All right, what's the most important room in anybody's house when it comes to hot water? All right, you know those 2 rooms. All right, it's going to be the people that pay the bills. All right, it's going to be, the first one is going to be the master bath, and the second one's going to be the kitchen. All right, that's where you want to put these things in to make sure those 2 rooms have hot water all the time. The kids' room, who cares? Don't worry about the kids out there. All right, we're going to take care of the parents first. So you put those in each one of those spaces. Dedicated return line. All right, yeah, we try to get that the furthest down the line as you can, and run that pipe back, or at least about 60% of the way there. It doesn't have to go all the way. You can get 60% of the way there, which is going to account for about 90% of the water, because the big pipe is on the beginning part of the pipe of the run, and then it gets smaller as we go out. All right, John, is this you or me now?
That's still you.
That's still me. All right. Price for the 006E and the hot link valve. Yes. Check with your wholesaler. They're going to have those prices for you guys out there. So check what's in stock, which way they have it. I honestly have no clue. All right. I don't keep pricing in my head, and I don't want to. But check with your local wholesaler on those things. These things are all readily available in stock all around at different places, and also in stock at Wales Derby too. So now here is going to be your tankless solution. So if you're looking at a tankless solution and or tank, it doesn't have to be just tankless, but the other solutions we had before are not for tankless. And now we're not using an ECM circulator, but we are using a bigger circ, like a 008 or a 0011. And the Taco Genie is probably one of our greenest systems that we have out there, meaning it uses the least amount of electricity, because this circulator is only going to run based on the homeowners. It runs on command, all right, like a Genie should, right? So how it runs on command is based upon a motion sensor or a button activation that the homeowners have to press. So either one of those things make the circulator run. So I like the motion sensor, because then you don't have to think about it. So let's say you put a motion sensor, and you can put as many as you want. You put that in a bathroom, and you put it over the doorway in the corner. So when you come walking into the room, it says, hey, there's probably going to be a need for hot water in the next couple of seconds. So this thing is going to kick on the circulator, and it will run for about 10 to 45 seconds, depending upon the system that you have there, and get you that hot water quickly. So it's only when you're actually walking in, not giving you that window of opportunity like we showed you before, or widening it out and things like that. It's going to run for a quick shot and be done. And it's done by that push button or motion sensor. Now, this is also designed as an under sink install. So the circulator is what goes underneath the sink. It's not just the hot link valve like we talked about. The circulator will go at the sink. We're going to use the cold water supply as the return going back, or as a dedicated return line, your choice on the installs. But for your crossover style, the circ goes underneath the sink, and it comes as in a complete kit like you see here. So you've got some shutoff valves. This is showing a 0011 that's flanged. The 008 has a sweat connections on there, or threaded connections, I'm sorry. These T's, you're going to remove the existing valve that's there, compress this side onto the pipe coming out of the wall, put the valve back on here, and this connection is this corrugated stainless pipe that will then connect up to the circulator itself. So this is how we have it as a kit. It comes with a push button. So the push button here is maybe for those high traffic areas, like a kitchen space, where you don't want the sensor tripping it off all the time. The homeowner actually has to push the button to get the water to run, or use the wireless one. So the motion sensor and the button switch, these are hardwired. They're not wireless. So you do have to wire it, and it is actually real easy. Coming off the circulator itself, you'll see 2 wires. One of them's for 2-wire button switches, and 3 wires are for the motion sensors. All right, is this motion sensor offered for the previous circulator with the hot link? It is not. All right, this is all part of this circulator in the controller. It is just on this here. Is this Wi-Fi or Bluetooth capable? Interesting question. I have seen people take this system or actually just take their own circulator, put it underneath the sink, and they wired it up to Alexa. And they just said, hey, Alexa, turn on that switch for 15 seconds. And that's it. That's all they did. All right. So I thought that was pretty unique and interesting. We are working on other versions of this. This has been out with us for at least 10 years. We've had this out already. So we are working on new ways to do that. Putting it on a Wemo switch. Yeah, definitely. That's a good idea too. All right. I actually have the lighting in my home office right now on a Wemo switch because I got a halogen lamp sitting over there and I leave it on all the time. So I just put a Wemo switch on it the other day and said, all right, only stay on for 2.5 hours because that's usually how long I'm down here for a webinar, and then I leave and I don't want to have to forget leaving it on all night long. So I'm down in the basement space. This is my cave from working from home right now. So like I said, tank or tankless style water heaters here. So let's take a look how it's installed. All right, we take this thing and put it in a sink underneath that vanity, maybe the furthest one down the line. And again, we're going to use the cold water supply as the return coming back into the water heater. And you can put as many motion sensors or button switches as you like in a project. So you can put a motion sensor in every bath. It will just make that one circulator run. No, it's only one circ, but many motion sensors. I like to actually put the motion sensor, let's say you have a bathroom at the end of a hall, put it in the hallway. All right, so this way when you walk down that hallway towards that bathroom, whatever, if you've got two bathrooms coming off of it, it'll kick on that way. And the other thing that we have to really minimize the runtime, it has a temperature sensor built into the circulator. Now the circulator's not looking for a temperature, it's looking for a temperature rise from when it was activated. So for example, if the temperature, the water temperature in the hot water line has cooled down to room temperature, that's usually our issue. It reaches 70 degrees. Now the cold water is also 70 degrees at this time. You walk into the bathroom, you trip the circulator on, the sensor immediately says, hey, it's 70. I only need to run to 78. So the pump turns on, pulls the water out of the water heater itself, in the meantime putting the water back in, and as it's pulling it out, it's 120 right behind 70. I mean, we're not looking at far apart. We're looking at inches apart from each other, between 70 degrees and 120 degree water. And as it comes up and hits the sensor itself, once it gets to 78, boom, we shut down. That means we know up here at the valve, it's going to be $120 right there, available at the fixture. Now, the other thing that keeps this circulator off is the motion sensor. We've got a 4-minute lockout on the motion sensor. So if you walk into the room, walk out, oh, nuts, I forgot something, you walk back in, it doesn't care, the sensor's turned off. And then the second thing that keeps this off is it will not kick back on again unless the water temperature drops below 99 degrees. Once it drops below 99 degrees and it's tripped, it could turn on again. But then it would probably turn on for a much shorter period. So that's why it's only 10 to 40 seconds of runtime that we see out of these things. All right. How we doing out there, people? So, and here we show you the dedicated return line style. All right, where you're going to tie back into that water heater, whether it's tank style or tankless with the Genie. Whoops. Before we go further, hang on, don't see that. What size do you need? Well, we have these as 3 different units, a 006, 008, and 0011. The 006 version would be looking at a tank style system and probably dedicated return line, where we're not doing any crossover style connections. That's where you're going to use that 006 version. But if you're looking at your tankless units, right here in the middle of the page, we're showing you the length of pipe and also what size of the home. And what I mean by size of the home here, small or medium, that's your 1.5, 2 bath house. All right. And that smaller home is going to be less than 60 feet away. So when you have that 1.5, 2 bath house, we're also looking at smaller water heater. All right. We're not looking at a large water heater here. We go to large to commercial. That's where we're looking at a 2.5, 3 bath home, and we're over 60 feet away. That's when you want to put in that 0011 in the system itself. Sound good, everybody? Any questions out there? All right. Any questions at all? Make sure you post them up there. Just to want to make sure that, one, we're not talking to ourselves. Two, that we didn't freeze up and you guys are just looking at me not moving. So, all right, we're doing well here. You guys are the best class that we've had all day. All right, I'm going to turn this back over to John now. Thank you, everybody.
Great, thanks, Dave. So we're gonna hop into mixed valves and go through the different mixed valves and the reasons why. So there's 3 main reasons to install mixed valves. Number 1 would be to prevent scalding. So over 6,000 injuries a year based around people hopping in the shower and getting scalded. Not a comfortable place to be. We also have the National Safety for the Kids campaign. Usually young children do not sense water temperature as fast as an adult would. So we want to make sure that, we're not burning the kids up when we put them in the shower. So mixed valves is just best practice. 34 deaths a year of all ages based on scalding, and 120-degree water at a faucet doesn't work. We also have to remember that in a tank style water heater, there's a phenomenon called stacking that takes place. So we may have the target temperature in the water heater set at 120, but as we fire that unit for small draws, if I'm in my kitchen and I do 10 or 12 small draws, that may fire the water heater and I'll get higher temperatures at the top of the tank. That's referred to as stacking. So we have the potential to stack up to 155, 160 degree water in the top of that tank. When we turn on a faucet, that hotter water is going to be working its way out to, whether it's the shower, the kitchen sink, the bathroom sink. We're going to get much hotter temperatures out to the faucet. So number 1 reason to install a mixed valve on an installation would be scalding. So this just goes through and shows us, the amount of time it would take to get a 2nd degree burn at all the different temperatures. So normal shower, approximately 110 degrees, we're good there. 116, you'd have to be in the water for quite a while. But when we get to 120 degree water, 9 minutes for a child, or not 9 minutes for an adult, 1.2 minutes for a child. So that happens rapidly, delivering 120 degree water to a faucet. And we can scroll on down the line. If we do get that stacking of water in the tank, it will mix with a little bit of the cooler water that's in a pipe, no doubt about it. But, we look at 140 degree, doesn't take very long and we can give a child 2nd degree burns. So again, scalding, one of the number 1 reasons why we would put a mixed valve in. Another reason, Legionella protection. So 8 to 18,000 cases per year. Usually every summer you hear about this, usually with a chiller type system, but this is also a real problem in our industry. 5% to 30% of those cases could end up in fatality. Why? 68 degrees and below, Legionella is dormant. So if we have a water heater or no water, just a well tank sitting there at 68 degrees in our basement, no issues, no worries. But when we start to heat water up and we get between 95 and 114 degrees, that's when Legionella bacteria, it's ideal time for it to start its growth. And that's like our water heater temperature. So this is why, again, number 2 reason is Legionella. So that's why we want a mixed valve. If we have a tank set up to 131 degrees, which we don't want to deliver 131 degree water to a faucet, hence the mixed valve, that will start to destroy the Legionella's bacteria. And in 5 to 6 minutes or 5 to 6 hours, we'll have cleaned that tank up of any bacteria within the tank. If we store the tank at 140 degrees, that'll destroy any of the Legionella's bacteria in 2 minutes. So I can't deliver 140 degree water out to a faucet or a shower because I'll have, scalding taking place in those devices. So at 158 degrees and above, That's basically, you know, dishwasher type water temperatures. That's our disinfectant range. So if we operate these tanks at hotter temperatures, we need some way to mix them down to satisfy the demand at the faucet and make sure we're not going to hurt the end user. The third reason would be create capacity. And how do we create capacity? There's several charts here that give us an opportunity to calculate recovery time and rates of hot water and different things along them lines. So this one here, basically, we're looking to deliver 112 degree water. The incoming water is 50 degrees. The storage tank is 140 and the incoming water is 50. So what that does is this is going to give us the amount of water we're stored in the tank. So that gets us down to another formula. 62 divided by 90 is a 0.69 storage factor. So this is, we're talking about it like an indirect here. So 34 gallons of storage in that tank, multiply that or divide that by 0.69, you're going to have 49 gallons of hot water within that tank. So create capacity. Why would we want to do that? The homeowner just paid $10,000 to redo their bathroom, but no one ever addressed the hot water. And now they have a rain head in that bathroom, or they put in a large tub in the bathroom. So they need to support that with additional hot water. And that 40-gallon tank or 50-gallon tank that they have in the basement is not going to keep up with those larger demands. So by adding a mix valve, we can elevate the water temperature within the storage tank, and we can deliver upwards of 50% more hot water to the new bathroom. Your best performance out of a mix valve, you want to get right around that 27 degree differential range. So your storage temperature in the tank, we would like to see that approximately 27 degrees higher than what you're trying to deliver the water at. And that will give us the ability to potentially increase the volume of hot water that storage tank can deliver by almost 50%. So a few years back, about 5 years back, the government changed the regulations, and all the water heater manufacturers had to take and add more insulation to their tanks, and the tanks all became larger. So if you were in a scenario now at a job in New Jersey where they had 80-gallon electric water heaters installed day one, well, they're all coming to their cycle life, and they're all starting to be replaced. And the 80-gallon tanks, there's just not there, and if they were there, they wouldn't fit because of the additional insulation. So now what the contractors are doing is they're going back there with 50-gallon tanks. So the homeowners have been in there for 8 years. They're used to the performance of their 80-gallon electric tank. Now they're putting 50-gallon tanks in. They're starting to run out of hot water. So we got called in, and we showed the contractor he can go to this mvcalc.wellsdarby.com, and that gives you the ability to put in your tank that was there that you're replacing in volume, the new tank that you're putting in, and it will automatically calculate a storage temperature for that new tank. So let's say the 80-gallon tank was there, it was set at 120. You replace it with a 50-gallon tank. You do need the same performance out of that 50 that you were getting out of the 80. So you would elevate the target temperature in that tank, let's say to 150, 155. And when you elevate that to 155, you install the mix valve. Now your delivery temperature will be the same, and you're going to get a longer range of performance out of that tank to get you closer to where that 80-gallon tank performed at 120. So adding capacity is one of the main reasons to put a mix valve on there. The second reason would be obviously to keep the people, the end user, safe when they turn on the hot water. So in the Taco world, we have several different mix valves. This is the 5000 series. Again, as Dave said earlier about the 006s, all of these fittings are purchased separately. When you buy a mix valve with Taco, you get just the body. And this right here would just be the body. And then you're going to purchase whatever type of fittings that you use, whether it's a PEX fitting, a crimp fitting, a solder fitting, whatever type of fitting you use, that's what you're going to order. So we have them in sweat, 1/2, 3/4, and 1 inch, a barb PEX fitting in 1/2, 3/4, 1 inch, threaded 1/2 and 3/4, C PVC in 1/2 and 3/4. This 5000 series is ASSE 1017 approved. The range is 85 to 176. The hot water side, we can handle 120 to 180 degree water going in. We have a minimum flow rate. So to make this mix valve work properly, we need to get at least 1 gallon of flow across the valve, and that will allow it to mix properly. And our maximum flow rate across the valve is 20 gallons per minute. It will come from the factory preset between 115 and 120. If you need to change that, this little green top pops off. There's a triangle tapped in here. You flip that upside down, you put that on a valve. That's how you would adjust the valve. All right, that's the 5000 series. Bunch of different options there. The 5120 series, this one here comes factory locked at 120, ASSE 1017 and 1070. So this can be as a point of use. So under the sink is an opportunity here. Range 85 to 120. Inlet hot water 120 to 180. Cold water 39 to 80. Extended range, but these are locked at 120. So you can go up to 176, but you won't see that. These are locked at 120. Minimum flow rate to get it to mix properly is 1 gallon, and a maximum flow rate is 14. In the lower picture here on the right side, you'll see each mix valve we offer has this union type device with a stainless steel temperature gauge on there. So that's an option if you want to have a temperature on your mix port. You can see your delivery water temperature by installing that gauge. That's our 5120 series. In the 5120 series, I think this is the 24 and 25. We also have a large volume. So this will, we need a minimum of 2.5 gallons of flow. So make sure you hit that minimum so the valve will work correctly. These are in 1 inch, 1.25 inches, and these are sweat only. Temperature range, same as the other ones, 85 to 176. Hot water inlet temperature, 120 to 180. Cold, 39 to 80. Maximum flow rate here, going to get you a little higher at 27.2. And they're also going to come factory set at between 115 and 120. So this would be for a higher flow rate. And the key item here is higher flow rates. Just make sure we hit our minimums so that the valve will work correctly and deliver the hot water you're looking for. Also ASSE 1070 approved. This is a point of use or on the water heater itself. So this is our 5123 series. Again, 85 to 120. That's it, 120. Temperature range for the hot water coming in, 120 to 180, 39 to 80 on the cold. 1 gallon minimum flow rate, a maximum flow rate of 12, factory set 115 to 120. So this right here would go right onto the top of the water heater. This is a 3/4 tapping on the bottom. 3/4 tapping going to your hot water within the home. Right here, this little port marked with an R, that has the ability to accept a recirc line. So if you have recirc within the house, you can pipe it directly to here. And then this valve has the ability to check valve here. We put a piece of stainless steel in the kit. You buy it as a kit, and then this will have a stainless steel line that'll come over to the cold water, and then that's where your cold water will come in, mix with your hot, and you'll set your target temperature right here, plus and minus, and then you'll get your delivery temperature going out to the home. So that's the 1023. So that's our mixed valve lineup. We'll take our 4th poll question and we'll get this wrapped up.
All right, 4th one, gentlemen. Why is it best practice to install mixing valves on all hot water heater installs? Already about 50% here, so people paying attention. That's good. Someone made mention that the mixed valve calculator isn't working, John. Have you used it recently?
I was on it 2 days ago. I'll double check it. I
was just on 30 seconds ago and it's working.
Okay.
Okay. Thank you, Dave.
Thank you
So
both.
maybe it was just the link that you found or something like that, but I actually just Googled MV Calc and Wales Derby and it popped right up for me.
All right, I think we're pretty good. We're gonna close a poll here, and we'll see some results. And 88%, all the above, all good reason, preventing the growth of
Right.
Legionella, scalding, and of course, increased water production, hot water production. Very good.
So one of
Fantastic.
those things too, when we look at that poll, what we're looking at there is, right now across the country, every place has a different area in requirements. And 99% of the time when people are using a mixing valve, it is for that scald protection because that's what code calls for. And also prevent growth of Legionella. That's something important to remember that we've, as us New Yorkers, we've heard of this already in our area. Now, yes, it is not to do with plumbing systems. We have heard about it in our chilled water towers, things like that, and chillers. But it's still in the minds of homeowners that are out there. And make that, you're doing any type of work in somebody's home, ask them, do you run out of hot water? And they're probably going to say, yeah, they do. And again, it's all these things that we talked about today was trying to make domestic as best as it can be in people's homes and increase their expectation out of it. Right now, expectations of a plumbing system to a lot of homeowners are really low, as in hot on the left and cold on the right. And that is it. All right. They are used to running out of hot water, waiting for hot water. All right. Then, of course, water leaking all over the place. So these are an avenue for you that homeowners have no idea that's out there. And, the statistics that I know in hot water research, less than 2% of homes have it. And we know almost everybody needs one. Leak detection, even less going on out there. So mixing valves just increase the volume of water that they have in there. So for example, in my house, all right, my house, like I said earlier, my house was a family of 2 and it jumped to a family of 6 in a short amount of time period. I had a brand new indirect tank, 35-gallon indirect tank. It was perfect. But then went to a family of 6. I dropped the mix valve on there, cranked the temp up to 160. I send out 115, and we have all the hot water in the world. So, so just to make domestic better, feel like a hero to your customers. When you're in their house doing any type of work, ask those questions. They're not going to want to pay for you right then and there, saying, you know what, you're already there paying them. They're paying you for some work that you're doing, but they'll remember that you can help address the issues that they have and correct it and go away from it. One thing to remember, offer it to them. Definitely offer it to them, because you never know what somebody's pain points are, especially when it comes to domestic hot water. Never become your customer's financial advisor. All right. You tell them how much it is, and that's it. Say that's what it is. And I do it all the time. I know I meet lots of homeowners in my job. I also meet lots of homeowners because of my wife being involved in Girl Scouts, PTA, all this other stuff. And there's always some sort of meeting happening at my house. And I walk in the house wearing a Taco shirt, and people look at me a little funny, and they're not sure because they don't see the Taco Bell logo on there, and they think, oh, what does he do? And I don't talk heating stuff. I love heating. I love hydronics. I talk the plumbing stuff. And everybody always says, I talked about research and things like that, and they're like, wow, that's cool, right? And then the conversation always turns to how much. Okay, well, I don't know. I'm not sure of your house. I don't do installs or anything like that. I can hook you up with a couple of people if you'd like, but anywhere between $400 and $900. And the next statement they always say to me, really? That's it? Take their money if they're going to give it to you. All right. You're providing them a solution to a problem they didn't know they had. All right. Now that they realize it, they're going to want to fix it. Okay. So it's all over the place. A couple of the questions that I see here. Can the valve be installed without a recirc loop and still be as effective? I'm not sure what you mean by that. You're talking about a mixing valve, or you would talk, maybe that water heater mount valve is probably what you're talking about, Alexander. That would be yes. You don't need to have a dedicated recirc line. There's already a plug in the water heat mount valve. You just take the plug out if you're adding recirc into it. So excellent. That's it. Awesome. All right. Any other questions out there? Please bring them in. Sorry, John, I just jumped in there. I was having
No,
some
that's
fun.
good. No, one other thing I wanted to touch on too, the leak breaker. We've added another feature to the leak breaker that'll actually exercise and make sure that there's no buildup on the inside of the valve, calcium buildup on the inside of the valve. So that'll actually exercise itself. We have a contractor in New Jersey. He does not do a water heater install without using a leak breaker, just from a liability standpoint. He just does it. So a lot of opportunity here. I think this is eye-opening for a lot of contractors. You know, it's rare that, you know, we're so engaged in the heating world. It's very rare we talk about the plumbing side of things. But again, I think Dave is 100% right here. This is more about asking the questions to the homeowner and then educating the homeowner as to what's available to them and give them the option. We don't know, you know, again, we don't want to judge where they spend their money, nor do we want to tell them what they need to do. We just want to give them the options and then they can make the decision. So thank you everyone for participating. We'll leave this open for a few minutes if you have any additional questions. If you would like us to contact you, you can easily go into the question box and give us your information. We'll be happy to reach out to you and help you with any of these products that you need. And that's all we have for you today. So thank you very much. If you pay attention to the Wells Darby website, we have a bunch of these different trainings going on online while we're all pretty much hunkered down, working from home. Look forward to seeing more of you in some more of our online training. So from the Wells Darby standpoint, thank you very much.
Also, before you sign off and before we sign off, if you didn't notice it on the right-hand side of that toolbar under the handouts, we have put up there a couple of things to download if you'd like to take a look at the plumbing only catalog from Taco, and also the future classes that Wales Darby is doing is listed over there on the right side. So take a look there, download it. So this way you have that for your reference. If you're looking for hard copies of the plumbing catalogs, obviously contact your Wales Darby salesman and or check out your wholesaler. They may have some of those in stock too. So excellent. Thank you for coming and hanging out with us for a couple hours this morning. Greatly appreciate it. We always know there's never a good time for training classes, and this is probably the best way that we can do that to get it out to you guys as we're all sitting around and you know, hunkered down and staying safe out there. And a lot of this plumbing stuff that we talked about today, especially with hot water, homeowners are home washing their hands. The CDC is telling us, hey, at least 20 seconds in warm soapy water, not cold soapy water, all right, to protect ourselves. So enjoy your day, people, and we'll see you out there eventually.
Thanks, everybody. Take care.